Welcome to Maths for You channel, a past question on mechanics. A lift moving in a mine pit of depth 4D meters begin to move vertically downwards from the rest from a point A at time t equals 0. First, it moves a distance d meters with a constant acceleration half g meters per second squared. And then it moves with the velocity attained at the end of the motion for another distance of d meters. The lift then moves the remaining distance with a constant retardation, so slowing down, so as to come to rest exactly at the point B at a distance 4d meters below A. Sketch the velocity time graph for the motion of the lift. Hence, find the total time taken by the lift to move down from A to B. Okay, I put a little sketch. The lift is sort of starting from, say, its ground at point A, and t equals 0, d, the distance equals 0, and the velocity is 0. Start from the rest. And then I travel with the acceleration half g meter per second squared for d distance. So the second stage, after the acceleration, the time taken to reach that, travel that d was t1, and the distance is d, and the velocity attained at the end of that d distance is v, taken as v. Then it travels with that velocity. So the v attained velocity is a constant velocity. So the acceleration is 0, and travel for another time, which is t2. So the total time from the beginning is t1 plus t2. And the distance, of course, d is now 2d because there's another d, constant speed, travel another d with the constant speed. And the third stage is actually traveled with the slowing down, so retardation. So the minus acceleration is negative. It's starting from the last stage of the travel, and the time, the total time is t1 plus t2, t3 from A to B. This is B, A to B, t1 plus t2 plus t3. D is 4D. The velocity is 0 because it's come to stop at B exactly. So now we've been asked to draw a VT diagram. So the x-axis is t time, the v is the y-axis. The first portion of the travel is acceleration g over 2. So I just put theta. It's d distance, so the area of the triangle is, because of the VT graph, area under the curve would be the distance. So that's d. Then constant speed, so it just the acceleration is 0, therefore it's in a parallel line to t. So that again travel t2, just that constant speed traveling is t2. And then again slowing down, this come to stop, starting from A and stopping at B. So it's come to stop again, that 4D, the total distance, so first D and the second D, and then rest, of course, 2D. So the first stage is time t1, constant speed t2, and the retardation is t3. From the first triangle, this VT diagram, the triangle V over T. The V is the vertical or opposite over T1 equal tan theta. But the tan theta is the acceleration or gradient. So tan theta equal half G. So V over T1 equal half G. From that, we can find V equal half GT. So I just call it as equation A. Then we use the distance traveled. This is actually the velocity attained at the end of the first first part of the travel. And the distance travel is the area of the triangle, that is half time the base time height, that is half time t1 time v. From that half t1, and then v, we know that, so just substitute for that, because we don't want v. We're going to keep that everything into time. That's the question. So half t1 times half gt1, that give us d equal quarter gt1 squared. Second one, so they travel with a constant speed. So the rectangle, the area of a rectangle is give us the distance, another d. D equal v times t2. The time they travel with a constant speed is t2, and v is the vertical. But we know that half gt1. So for vt, substitute that half gt t1 times t2. Then d, we have found here d from b, equation b, we know that d. So I'll just substitute that for d. So that d is quarter g t1 squared equal half g t1 t2. So t1 and the 2 cancelled out, g cancelled out, 2 and 4 2 common. So what we have on the left hand side, and cross multiplication of course, left hand side and the right hand side. I just put right to left. So the right hand side is just t2, the left hand side is t2 over 2. So now t2 in terms of t2. So half of t2 is half of t1 is t2. So that's we found. Then the third stage. Third stage is the retardation. Again, the triangle. So 2D, the distance traveled. So the area of the triangle should be equal. 2D equal half time t3. That's the time taken, or the base is t3. Time v. V, we know that this is v. We know that half v is half gt t1. So we're just trying to get everything in the t1. 2D, again d, we know that d is quarter gt1 squared. So 2 times quarter gt1 squared equal half t3 times half gt t1. So the t1, the squared cancelled out, and gg gone, and the 2 and 2 common. Then if it's 2t1, right, sorry. There are two twos there, 2, and the 4 gone, cancel out. So what we have on the left hand side, 2t1, the right hand side is t3. So the t3 is 2t1. Now t3 in t1, t2 in t1, and t1 t1. So the total time is, I just put a t, is what? T1 plus T2, 3 plus T3. So T1 is T1, and then T2 is a half of T1. So half of T1, and T3 is 2T1. From that, 7 over T1. From the equation, we have D equal quarter GT1 squared. From that, T1, from that, we need one cross multiplication, 4D over G. Then T1 equal square root of 4D over G. 4 out of the square root is 2D over G. Of course, we don't need to take plus or minus when we root, because the time is positive always. Time a positive. Time always greater than 0. So T1 equals 2 dg over. So the total time 702 times 2 square root of d over g. Then 2 to cancel out, 7d over g, square root of d over g. That's the total time. That is what we have been asked to write. Hence the sketch the graph, which we did, and find the total time taken by the lift to move down from A to B, which is capital T, T1 plus T2 plus T3. That is 7 square root of d over g. Thank you. Please subscribe the channel and share the contents with your friends and students, other students. Thank you.